Okay, we must have a test coming up pretty soon on sections 2.1 and 2.2 because that's what this video is going to cover, some review problems to get you ready for that test. So let's see here. Number 1, directions say determine if this relation is a function and then give the domain and the range. So is it a function? Well, let's look at all our x values. Are they all different? We got a 10, a -2, a -1, and a 5. Since all of the inputs are all different, we can immediately say yes. That's supposed to be an S. Yes, it is a function. The domain. The domain is, of course, all our x values. So I'll do a little bracket here, and then we'll put in there. I like to put them in ascending order. -2, -1, 5, 10. That is a 2, trust me. Okay, and then the range. The range is all the y values. So I'm going to do another bracket. And let's see my y values. I have a 4, another 4. There's a repeater, and we only put the repeaters in once. And then I have a 1 and a 6. So 1, 4, 6. There's our range. Again, don't put the repeaters in twice. On to question 2. Determine whether the equation defines y as a function of x. That means we want to solve for y and see what happens. Now, just to compare and contrast, here is the problem we are given, x plus y cubed equals 8. And I want to compare that to the same thing, but with a y squared instead of a y cubed. Okay, to solve either of these for y, step 1 is subtract x. So this is y cubed equals 8 minus x. And then over here we'd have y squared equals 8 minus x. And now we want to get y alone, so of course we're going to root both sides. Here on the left I'm going to cube root both sides. And here on the left I'm going to square root both sides. So let's see, here on the left the cube and the cube root cancel, and we have y equals the third root of 8 minus x. On the right here, the square and square root cancel, and I'll have y equals the square root of 8 minus x. But let's not forget, when we square root both sides of an equation, we have two roots to think about, the plus and minus. Do we have the same scenario with a third root or any odd root? No, we don't. We don't have a plus or minus. So here on the right, this would be our automatic disqualifier from being a function. The easiest example I can think of is if we plug in x is equal to 0. If we plug in 0, we get 8 minus 0, which is 8. So we have two answers, a positive root of 8 and a negative root of 8. So for the one input of 0, we have two possible outputs. And that, if we plotted those as points, we'd fail the vertical line test. So as soon as we even rooted both sides, we had this plus or minus scenario that disqualifies us from being a function. When we take the third root, do we have to do the same thing? Is there a positive and negative root to come out of that? No, because it's an odd root. You know, for any one value we plug in, we'll get a distinct value coming out. So here, yes, we can define that as y as a function of x. If that was a square root and we square root both sides, the plus minus is our automatic disqualification from being a function. Here we want to evaluate at the given values and simplify. So we have g of something is equal to that something squared minus 10 times that something minus 3. Well, the first one, g of -1, well, -1 squared is +1. And then if we put in here a -1, minus 10 times minus 1 turns into a plus 10. And then we have our minus 3. 1 plus 10 is 11. 11 minus 3 is 8. There's our answer. For the next one, we're plugging in a quantity, x plus 2. So if I plug x plus 2 in here and I FOIL it out, I square it, I'm going to have x squared plus 4x plus 4. And I would also put the x plus 2 in here and distribute the -10. So that's going to be a minus 10x minus 20, minus 10x minus 20. And then I have my constant minus 3. Well, let's collect like terms. X squared. We have a 4x minus 10x is a -6x. And then we have, this would combine to a -23. -23 plus 4 is -19. There's our final answer simplified down as far as we can go for part B. Now the last one, we're plugging in a negative x, and I guess I can use this now. Negative x times negative x is positive x squared. Here the two minuses will hit and become a plus 10x, and then minus 3. So it's exactly like our original equation, but that minus got changed to a plus. Everything else is the same. Here we want to find some info from the graph. The first thing they ask is the domain. Domain is our x-axis. So if I look at as far left as we go on the x-axis and as far right as we go on the x-axis, it goes from 0 to 5. Now this endpoint is included, signified by the colored in circle, so that would be a bracket. And above the 5 we have an open circle, so there'd be a parenthesis there. On the other hand, if you like set builder notation better, we could have the set of all x such that x is between 0 and 5 with the or equal to between the 0 and the x. All right, a range. Range is the y-axis. So we look how low we go on the y-axis and how high we go. That goes from negative 1 to positive 5. Negative 1 to 5. Again, our bottom dot is colored in, so that would signify a bracket with the negative 1. Up at the top, we have an open circle as high as the 5 goes, so that would be a parenthesis. Or with set builder notation, the set of all y, such that y is in between negative 1 and 5. And the or equal to goes with the negative 1, so we'll have that in there. Okay, x-intercept. What's our x-intercept? Well, we could say x is 2 is where we cross the x-axis, or if you like a point, 2 comma 0 would also work. And our y-intercept, well, we don't cross the y-axis, but we do touch it here at negative 1. So our y-intercept is negative 1, or you could write it as a point, 0 comma negative 1. The last thing, we're asked to find a value of the function at the input of 3, so f of 3. Find 3 on your x-axis, your domain. If I look down, I do not see the function, but if I look up, I hit the function right here. What's our value on the y-axis? Positive 1. And that's question 4. Number 5, we're talking about decreasing, increasing, and constant intervals. Let's see here. The first one, where is the function increasing? So where's the function going uphill as we read it from left to right? Well, here we're going uphill, up, 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 and we're going uphill until we hit the peak. So for our increasing interval, we go from negative infinity until our x value of negative 1. Okay, next part is decreasing. Well, we're here at the peak. We're at the highest we're ever going to go. Now as we read the graph left to right, and now we're going downhill. So this interval picks up where the previous one left off at negative 1, and that's going to continue for the rest of the graph, so that'll take us to the positive infinity. Okay, and last but not least, where do we have an interval in which we are constant? Are there any flat parts of the graph? No. So that would be NA, not applicable, or you could write none. Anything to tell me that there are no constant intervals on the graph. Number 6, even, odd, or neither. Well, you could do the algebraic test if you prefer all that algebra, or I notice I have an odd exponent, so it would be an odd function, but this constant will knock us off the origin. So this is going to be a neither. The last one we have here, even exponent, so that is an even function. And just for the sake of argument, if there was plus or minus a constant, like plus or minus 10, would it still be even? Yes, it would be. Constants do not mess up even functions, but they do mess up odd functions. Number 7, piecewise. So we have to look here to determine which piece of the function our domain number goes into. Well, here's h of 7. Is 7 equal to 5? No, it's not. If it's not equal to 5, that x value goes in the top piece. So I'm going to have 7 squared, or 49, minus 25, divided by x minus 5, which would be 7 minus 5. And that gives us 24 divided by 2, which is 12. And there's our answer for part A. Part B, h of 0. 0 is not equal to 5, so we plug 0 in for both of these x's. which means they just go away. So we have 0 minus 25 over 0 minus 5, or negative 25 divided by negative 5, and the negatives divide out to a positive. 25 divided by 5 is 5. B, x equals 5. Or, excuse me, h of 5 equals 5. The last one's the easy one, h of 5, or excuse me, that was h of 0 equals 5. Now we're plugging in a 5. So we don't want to plug it in here because we are not equal to 5. We're exactly equal to 5. So we're going to plug that x in for any x's over here, but there are no x's to plug that value in for, so our final answer is just 10. H of 5 equals 10. One more, difference quotient. And I do like to color code these since I have my Mimeo here. F of x plus h. So the first thing I want to do is take this function, 2 times something squared, and I'm going to take out the x and replace it with the quantity x plus h. And now to finish off the difference quotient's numerator, minus f of x, and that's our original function, 2x squared. That is all divided by denominator h. So I am going to combine a couple steps here. If I FOIL this out, I'll get x squared plus 2xh plus h squared, and then I'll distribute the 2. So that part of the numerator will be 2x squared plus 4xh plus 2h squared. And then I have this other part, minus 2x squared, and that's all divided by denominator h. Well, what cancels? Negative 2x squared and positive 2x squared cancel. And now I have a divide by h. Both of my numerator terms contain an h, at least one h. So the denominator h will cancel out this one, and it'll knock the squared down to a first power. So what am I left with? 4x plus 2h. And there's our final answer. Alrighty, hope this helped. Good luck on the test.